Alright, so what is standard form and why is it even useful? Well, standard form is great when you have very big or small numbers and want to write it down in such a cool and convenient way. Well, let me give you an example. Suppose you had to write, I don't know, 60 billion, and well, there's a bunch of zeros. In fact, there's three groups of zeros, and you can't be writing 60 billion because you have to count. Instead, we would write it by how many zeros though. So we got 3, 6, 9, 10. So to write, we always write 6 times, and it's always powers 10, 10 to the power of 10. This doesn't really help, but the 10 here represents the number of digits before the first term, and it's always in sequences of 10. Another example would be writing something that's really small, like 0.00000000426. Okay, damn, that's a lot. And here's the same thing. Instead of a positive power, we're going to have a negative power because it's below, you're going numbers towards 0, and it's very tiny with tons of zeros. So we count how many zeros we have again. So I'll always start from here. So 1 plus 3 plus 3 plus 2. So we're going to have 2, 3, 6, 8, 9. So 9 zeros altogether. So first we write 4.26 times 10 to the power of how many zeros? 9. And we stick a negative sign. Okay, so this is always positive and this is always negative. This here represents the value. So always write the value for point whatever. 6 point whatever. Okay? It takes the form of a times 10 to the power of n, where n is a number of places the decimal point actually went. Okay, and that's it. So this is quite straightforward, and let's have a look at some examples to really get the feel of it. So number 1, so grade 4 question: express 133 million.5 in standard form. We'll have a go, otherwise we just do the same thing. So I always do one step at a time. So first I write 133.5, and we know because it's a million, there's going to be 6 zeros, so it'll always be times 10 to the power of 6 zeros. However, in standard form, remember, we need a digit. If you look in the previous example, a, where actually a I should have defined as 1-digit values. Value between 1 and 10. For example, 4 is between 1 and 10, 6 is 1 and 10. 133 is not between it, so we need to change it again to 1.335. Since we moved the 2 across, we need to add 2 more to 6, which makes it 8. Okay, quite straightforward. Now, how about if we wrote this one as an ordinary number? Again, this means how many zeros there should be. So we should have 4 zeros. So 1, 2, 3, 4. And you always stick in a nice point. And we copy the rest of the digits, 505. So again, 4 digits. Okay, so this is good and this is good. Now, this one will take some time. So let's try and understand what's going on here. So work out the following, write, calculate, express in standard form. First thing first, when we look at these values, we have a standard form here and a standard form here with different number of digits. Here we got 6 digits after the 3 and 7 after the 5. We should try and, in the way we word this, we have to make the powers the same. So what I would do, because 7 is higher than 6, I would inherently raise this one up to 7 and move this one point forward. I'll tell you why. So we keep the things at the same. And if we add it to 5.7 times 10 to the power 7, we just add up these values. And here we simply get 5.7 plus 0.32. Quick maths, we should get 6.02 times 10 to the power 7. And that's really it. You just move this forward, make this a 7, and you're done. Easy. I mean, there's loads of tricks and strategies, but I'm just showing you the fast tricks. But otherwise, this is standard form in a nutshell.